Hello, we the students from Thiagarajar College of Engineering are going to present a project on intrusion detection of wild animals into the farm fields. In the present scenario, the wild animals are detained outside the farm field by barbed wires. The probability of animals getting hurted is drastically high in this case. This project promises a foolproof mechanism to protect the cultivation lands, and of course, it won't hurt the animals. Now let's get into our project. This is our proposed system, and this is the farm field that we are going to use. The fence that you see is the fence that has been used presently, and to this we are going to use virtual electronic fence, which includes the phototransistor and the laser, which we call the laser interrupt module. And if there is an intrusion in this side, the data flows to the microcontroller unit. This is the microcontroller unit. This is Atmel Mega 328. This has been serially interfaced with the LabVIEW unit. And this is also connected to the two motors that are mounted on the cement post. And if there is an interruption on one particular side, the other camera turns to that particular side. And this data flows to the microcontroller. Next is the control center. Now let me explain you about the front panel of this VI. In this VI, there is an interrupt tab where two LEDs are present, intruder on the left and intruder on the right. If there is an interrupt on the left side of the field, the left LED glows, and similarly, if there is an intruder on the right side of the field, the right LED glows. In the camera 1 tab, you can see the frame difference images that are acquired from the camera. You can also increase or decrease the number of frames by increasing or decreasing the array index. In the camera 2 tab, the data is similarly acquired from camera 2. These are also frame difference images. This is the microphone tab. Here, the sounds of animals are recorded.
Now let me explain about the block diagram of this VI. The whole block diagram is arranged in a flat sequence structure. The microcontroller unit has been interfaced with LabVIEW via COM23. The microcontroller unit sends two kinds of data, L and R. Based on the data, the LabVIEW instructs the microcontroller unit to switch on the cameras. This VI represents the buzzer alert. The second part of the structure consists of a stack sequence structure, where the first stack consists of image acquisition VI. The second stack shows the frame differencing algorithm. The third stack shows the calling of MATLAB executable. The same is done for the CAM2, which has been placed in the third structure. The fourth structure shows the microphone data acquisition.
Now the two LEDs are green, which shows that there is no intrusion. This is the object that we are going to use for intrusion. If this object intrudes in this particular side, the other camera will turn towards this particular side. Now let's see what is going to happen. There is a red LED which shows that there is intrusion on the left. Now as you can see, the red light is glowing, which is indicating that there is an intruder in the left. The beep sound that you are hearing is due to some intrusion. Now the image is being acquisited from the cameras. Now as you can see, this is an image of an elephant, and when you increase the frame number, you will see that the elephant is moving. Now the MATLAB executable is called, and the frame differencing algorithm is carried out. Now as you can see, the movement of elephant is tracked. Similarly, image is also acquisited from the second camera. And the MATLAB executable is called upon for motion tracking. The image that you see is smaller because it is taken from the camera from the other side of the farm field. The motion is also verified by increasing the array number in the lab view. This is the microphone data that has been taken after the intrusion, which is the sound of wild animals.